Lecture number 10, the second law of thermodynamics, and we'll be doing the related problem today. Problem 7.46, find the power output and the low temperature heat rejection rate for a Carnot cycle heat engine that receives 6 kilowatt at 250 degrees centigrade and reject heat at 30 degrees centigrade. So we need to find out the power output, which is actually the work rate, and the low temperature heat rejection. So low temperature heat rejection would be the heat rejection at, and that would be QL. So we need to find out them too. Um, if you're looking at the Carnot cycle, so Carnot cycle would be efficiency of the Carnot cycle is equal to work done divided by the maximum supply. So something like this. So if I need to find out the work done over here, I need to have the efficiency and I need to have the high temperature heat or the heat received by the engine. So in this problem, I have got the heat in, which is actually 6 kilowatt. Uh, but yes, I do not have got the efficiency, and I do not have got the work done. So to find out the efficiency, so efficiency of the Carnot is 1 minus TL by TH. So putting the value of TL and TH, which is 250 degrees centigrade, is TH, while at 30 degrees centigrade is TL. Make sure you just convert them into the absolute scale before actually putting into the Carnot efficiency. So 1 minus TL by TH, the efficiency would come up as 42%. So putting them efficiency in this problem, work done would be equal to efficiency multiplied by the heat supplied, which is actually, or the heat received by the engine, which is 6 kilowatt. That is the work done would be equal to 2.52 kilowatt. Now, for the same thing, applying the energy equation, which is work done, total work done was, remember, was equal to heat supplied minus, sorry, QH minus QL. That was the work done for the Carnot cycle. So just we do have that QH, we do have W now. So putting them in here, you can find the low temperature heat rejection.